Hi everyone. In this video, I will be giving a demonstration of multi-level path analysis using lavaan in RStudio. And I've basically adapted a presentation by Heck and Thomas in their book, An Introduction to Multi-Level Modeling Techniques, MLM and SEM Approaches Using M+. So that's their 2015 book. So in this demonstration, I will walk through just some of the basic lavaan syntax to get you oriented to how to run this type of analysis using lavaan. And before I get started, I do want to mention that underneath the video description, you'll find links to the data and some additional information that you might find useful. So I hope that you do check them out. So before I open up RStudio and begin kind of walking through some of the analyses, I do want to kind of give you an overview of the type of data that we're working with and the model. So basically in Heck and Thomas's chapter, they're describing a model involving data from 12,445 employees, with those employees nested within 160 organizations. So the kind of main model, if you will, that they were testing looks like this. And they kind of go through a stepwise process of testing sort of a smaller model and then this model, and then they kind of prune out the non-significant paths in the last model. We're not going to do run through those models. We're just going to be focusing in on this main one right here. So with this particular model, you can see that we have employees serving as the level 1 units and organizations as the level 2 units. And our outcome variables are satisfaction with benefits and satisfaction with conditions. And so at level 1, these two variables are being predicted by gender identification, which in the data set is named female, and then ethnic or racial identification, which in the data set is named white. At level 2, you can see that we have sort of the ovals there for satisfaction with benefits and satisfaction with conditions. And so basically, that's just what we're doing is we're predicting the randomly varying intercepts at level 2. So the variables that we have at level 2 that are predictors include organizational context variables 1 and 2, or org1 and org2. There's really not any discussion or description about what these variables really represent in the chapter, so we're not going to spend a whole lot of time trying to interpret these effects substantively. We also have organizational productivity. That's the Z product variable that you'll see in the data set. And so that variable was serving as a mediator during their analysis. Okay, so here we are in RStudio, and I've already kind of set the working directory, and we'll be importing the data. Just to show you what I was talking about with the working directory, just go to Session, set working directory, choose directory, and be sure that you select the directory where your data is located. So the data is stored in a CSV file, so we'll just quickly import the data. We'll go to from text right here, and we'll select our data set, which is this CH4MV. So that's a CSV file, like I said. So we'll click on Open right here, and we need our heading, so we'll click on that as well. And then we'll click, it looks like everything looks okay, so we'll go ahead and import our data. So now we have our data. We'll go ahead and click on File, New File, and open up an R script, and this is where we will enter our code. So briefly, what we will do is just take a quick look at our data. When we imported the data, it was saved to an object called, or a data frame called CH4MV, just basically following after the original naming of our CSV file right here. So we'll just take a quick look at the structure of the data. We'll just go ahead and use the structure function str CH4MV, and we'll highlight that, click on Run. And just as we're looking at it, you can see that we have an organizational ID. That's going to be our identifier, our cluster variable. When we run our analysis, we have the female variable right here, white right here. Those are our level 1 predictor variables. Then we have org1, org2 serving as predictors at level 2. And then we have the Z product variable also serving as a predictor at level 2. Just to take a quick look at the data structure, we can just type in head ch4mv right here, or we can tab back up here if we wanted to. But just to show you again, we'll just click on run right here, and you can see our variables. There's organizational ID, female, white, org1, org2, and then our Z product variable right there. So now what we're going to do is go ahead and load the lavaan package. So we're going to use our library function, type in lavaan right here to load it. We'll have to highlight this and click on run. So now lavaan has been activated or loaded, and now we can actually run our model. So I'm going to go ahead. The first thing that we need to do is to specify the basic model, and save it to an object. So I'm going to just call this model 1, for lack of a better naming system. We'll type in our arrow, basically which is just essentially a lesson sign followed by a hyphen right there. So that's our assignment operator. And then what we do when we're typing in our model into lavaan, we have to situate our model between two single quotation marks. So we're going to start out with the first single quote right here. We'll go down to our next line down here, and then we're going to enter our text and everything, and then we're going to wrap it up with a end single quote. So just keep in mind that we have to save our model in this kind of way, so don't forget. So I'm just going to leave that last single quote in there. Hopefully I don't forget about it as I start typing everything in. So when we are typing in our model, we need to make sure that we lay it out in terms of our separate levels. So I'm going to type in level, colon, and then 1. Okay, and then we'll do the same thing for the second level. So we'll type in level, colon, 2. Now I'm going to say this is really important. Do not type level 1 colon and level 2 colon, because if you try to run your model that way, it's not going to work. So it's specific to lavaan. You type in level colon 1, level colon 2. All right. So now at this point, we're going to specify our level 1 model. So let me kind of move this down just a little bit, give you a little bit more room to see. So now what we're going to do is we're going to type in our benefit variable. That's our level 1 outcome. And then we're going to type in a tilde and then follow it up with white, then plus, and then female. Okay, so those are our level 1 predictors. Basically, we're just laying it out like a typical regression, as you would when you're working with R and RStudio. So it's just basically, if you're using the linear model function, you'd be typing in the name of the dependent variable, tilde, and then the names of the independent variables separated by plus signs. So it's the same structure that you may be familiar with when you're working with the LM function. So we're going to do the same thing with the condition variable. So in this case, we're going to type in COND. And just by the way, just so you know, the benefit and COND or condition variable, basically they're referring to an employee's satisfaction with benefits and employee's satisfaction with working conditions. So these are the names as they appear in our data frame. So we'll type in COND, and then we'll type our tilde, then white, plus female right here. So once we've done that, we'll kind of move on down, and in the example in their book, they actually allow the endogenous variables benefit and condition to errors to covary. So we'll go ahead and allow that to happen as well. So to accomplish that, we'll type in benefit and then 2 tildes and then COND. Okay, so if you have 2 variables separated by 2 tildes when you're working with lavaan, that is allowing those variables, or in this case, the errors to covary. So now we're going to move on to level 2. And in this particular case, it gets a little bit more hairy, but because there's a few more variables to work with, but not too bad. So what we'll do at this point is we're going to start out by typing benefit tilde, and then the predictors of benefit at level 2. And remember that at level 2, we're essentially predicting the randomly varying intercepts for benefits, satisfaction with benefits and satisfaction with conditions. So basically we're looking at organizational level predictors of organizational variation and benefit, satisfaction with benefits and satisfaction with conditions. So we'll type in benefit tilde, and then we're going to type in org1 plus org2, and then plus z product. So if you go back and you kind of sort of think about that model I was showing you, we had 3 direct effects of satisfaction with benefits, which was org1, org2, and z product, with z product serving as the prospective mediator. So then we'll do the same thing for our satisfaction with conditions variable at level 2. So we'll type in COND tilde org1 plus org2 plus z product. And then we're also going to include our predictors of z product. So that's basically organizational productivity, which is modeled as a function of org1 plus org2. And then finally, we're going to add in the covariance at level 2 for benefit, 2 tildes, and COND right here. So all that is specified now, and we have our last bit, which is that end quotation mark that you see right here. So all we really need to do at this point, we need to go ahead and highlight all of this. And we'll click on run so that our model is now saved to an object. That object is called model 1, or named model 1. So now that we've done that, the next thing that we want to do is to basically run the model. And we want to save our model information to an object. We'll call it a fit object, if you will. And we have to give it a name. So I'm going to type in fit1, and then our assignment operator, and we're going to use the SEM function. So we'll type in SEM, and then in parenthesis, you can type in the name of the first argument. You can type it in as model, and then equals, and then the name of the model that we've kind of specified, which we called model 1. So you can do that, or you can just type in model 1 for that first argument. That would work fine too. We'll type comma, then data, and set that equal to CH4MV. So that's the name of our data frame. Then we'll type comma, and then we're going to type in cluster. So unlike the single level model, if we're using lavaan, in the case of a multi-level model, we have to use our cluster argument right here. So we're going to set cluster equal to, and then actually going to go to the next line here and type in org ID. Okay, so remember that org ID variable is in our data frame. That's the name of the organizational ID variable that we've got in our data frame, and that has to be enclosed in quotation marks. So make sure that you've got that correct. Okay, so once we've done that, then when we fit our model, the information is going to be saved to this fit1 object right here, and then we want to basically call up the information to interpret our results. So in this case, we use the summary function. We'll type inside the parenthesis here, the first argument will be the name of our fit object, which we call fit1, comma, and then if we want more than just a couple of fit measures, we can type in fit period measures, and we can set this equal to T or true. If you type in the word true, make sure that it's in all caps. So then we'll type comma. Then if you want R square values, you can type in R square and set that equal to T. And if you want standardized estimates as well, you can also type in standardized, use that argument, set that equal to T. So now we've specified our model. what we haven't done is actually run our model and then requested the summary information. So I'm going to go ahead and highlight both of these sets of code right here and click on run. And so it kind of takes a second here, but now you can see that we have our output. So kind of scrolling back up a little bit, you can see there's a little bit of a warning here. It's just basically indicating that one of our variables doesn't have any variance within some of the clusters. They're basically kind of identifying which clusters don't have, there's no variation in terms of ethnic identity, but basically we're still good in terms of running our analysis. So basically in terms of our output, we have our let me kind of scroll back up here again. You can see that we have the model results, the chi-square goodness of fit test right here. You can see the test statistics is 0, degrees of freedom is 0. Basically, we have a just identified model. So when it comes to really trying to evaluate the fit of the model, about the best we can do is look at the regression parameters and tests when we're evaluating the fit. But I will show you that you also get your information about the CFI, TLI, RMSEA. You get the standardized root mean square residual, both within and also between. But once again, our model is just identified, so there's not really much we can use or refer to these and have it be particularly useful. In terms of our level 1 predictors, you can see the regressions. You can see that we have the predictor white right here as a predictor of benefit, and you can also see our female variable as a predictor of benefit. Both of these are positive and statistically significant. When we look at predictors of satisfaction with conditions, right, at work, so to speak, we have white, female. Also, these are both positive and statistically significant. I will kind of show you too that if we kind of scroll, pull this out just a little bit, you can basically see that had we run the model and had a little bit more space, the standardized estimates will also appear in this row. So just to kind of show you what I'm talking about, because it's a little bit cluttered. Rerun it there for a second. All right, so now looking at it again, you can see there's our standardized estimates showing up in our last column here. So at any rate, so this was at level 1 that we were just talking about, the within level. Then if we scroll down, you can also see there's the covariance between benefit and condition at level 1, or at least the residuals at level 1. Then when we scroll down, you can see that there's the R-square values for benefit and condition as well. Then we have level 2 right there. And so then we've got org1 and org2 and Z product. All of these are serving as predictors of satisfaction with benefits at the organizational level. You can see that of those predictors, only the org2 variable is not statistically significant, but you see that org1 and the organizational productivity, both of those were positive and significant predictors of kind of organizational level satisfaction with benefits. Then in terms of satisfaction with conditions right here, you basically have the same thing going on. So the org1 predictor and Z product, basically organizational productivity, both of those were positive and significant predictors of kind of organizational level satisfaction with conditions. And then you've got the Z product variable being predicted by org1 and org2, and only org2 was a significant predictor. That was actually a negative and significant predictor of organizational productivity. Scrolling on down, you can also see there's our R-square values for that level. So there's for benefit, condition, and then for organizational productivity. Now, because we are running our path model, we've got a mediator at level 2. It may be the case that we want to test for possible indirect effects, to test whether the indirect effects of org 1 and org 2 on kind of organizational satisfaction with benefits and conditions, whether it's mediated by productivity. So we can actually do that as well. So what I'm going to do is I'm going to kind of go back up here, and I'll just kind of steal this code again, and we'll just make a few modifications. So I'm going to just kind of paste this in right here. I'm going to call this Model 1 V2, for lack of a better way of naming it. So when we are trying to test for indirect effects or testing our mediation, if you will, then what we have to do is we actually have to give our paths in the model labels, or at least the ones that are being used in the construction of the indirect effects. Now at level 1, there's, we aren't specifying any indirect effects. Basically all we have are direct effects that are going on. But at level 2, remember that we have org 1 and org 2 are serving as predictors of organizational productivity, and organizational productivity is a predictor of organization level benefits and or satisfaction with benefits at an organizational level, and also satisfaction with condition at an organizational level. So what we need to do then is to first assign labels to the paths that we would be using in the construction of those indirect effects. And then we also have to specify some additional estimands in our code, so that when we run our analysis, we generate the indirect effects. So what we'll do at this point is we'll begin by thinking about the predictors of the proposed mediator. So the predictors of the mediator in our model are org 1 and org 2. So what I'm going to do is I'm going to assign a label for the path from org 1 to Z product. And I'm going to call this or name this path A1. That's the label that I'm assigning for that path. Then from org 2 to Z product, I'm going to create another label. I'm going to call it A2 and add an asterisk there. So that's the structure that we're working with. So any label that you're assigning, you're going to type in the label and then an asterisk and then the name of the predictor variable. So that's what we're doing right there. Then we need our paths from Z product to benefit and condition. So in this particular case right here, then, if we're going to go from Z product to benefit, what I can do is I may assign this path right here be a label of B1, and I'll put an asterisk right there. And then for the path from Z product to our condition variable, we'll assign this a label of B2. So we'll have B2 times Z product. Okay, so now we've given labels for all the indirect effects that we are computing during our analysis. And just briefly going back to the figures, or the figure that I've shown you, I'll just kind of show you where those A1 and A2s and B1 and B2s are showing up. So basically it's like this. If you kind of go up here, organizational context variable 1, org 1 to Z productivity, this is the first path right there, and that's what we are assigning as A1. Then the path from organizational context 2 to productivity, we're assigning this A2 right here. Then from organizational productivity to satisfaction with benefits, at an organizational level, we're going to name that B1. And then from organizational productivity to satisfaction with conditions, again at the organizational level, we're going to name that path B2. So the indirect effect of organizational context 1 on satisfaction with benefits will be computed as a product of A1 and B1. Then organizational context 1 on satisfaction with conditions will be computed as a product of A1 and B2 right here. Then the effect of organizational context variable 2 on satisfaction with benefits will be computed as a product of A2 and B1. And then the effect of organizational context 2 on satisfaction with conditions will be the product of A2 and B2. So what we have to do, we've assigned the labels. Now we have to instruct the program to create estimates and then to carry out tests for those indirect effects. So at this point, what I'll do is I'm going to just kind of add a little comment right here. We'll just comment #, then level 2 indirect effects. So the first estimand that I'm going to create, I have to give it a name. So I'm going to call it IE1. So there's nothing special about the naming. That's just what I chose to name it. So I'm going to use the following. I'm going to type in a colon and then follow it by an equal sign. Okay, so this is the way that you specify estimands that you want to compute using lavaan. So now for the indirect effect of org1 on benefit, then I need to take the product of paths A1 and B1. So I'm going to type in A1 asterisk then B1. Okay, so and if I want to give it a little bit of a comment here, I can add a comment # right here. I'll just say org1 leading to Z product leading to benefit right there. Then IE2, then colon followed by an equal sign. So in this case, I'm going to specify the path from org2 to condition by way of Z product. So we're going to take A2 asterisk B2. So again, just kind of adding a comment, I'll say org2 leading to Z product leading to condition or satisfaction with conditions. Then IE3 colon followed by an equal sign, we'll take A1 by B2 right there. So adding a little comment here, org1 leading to Z product leading to condition right there, or satisfaction with conditions there. And then IE4 colon followed by equal sign, then A2 by B1. Z product, and then benefit. Okay, so that's basically all there is to it. Again, we need to make sure that we end our syntax with our single quote. Just like we started with a single quote, we have to end it with a single quote right there. So then following that, we're going to type in fit. I'm going to give this just a new name. I'll call it fit1 v2 for version 2. We'll type in then SEM model is equal to model 1 v2 for the model that we just specified above. Data, set that equal to ch4 mv. Cluster, we'll set this equal to org ID right there. And then finally, we'll type in summary, fit1 v2, fit period measures right here, set that equal to true, r square, set that equal to true, and then standardize, we'll set that equal to true as well. So now we can run our analysis. So I'm going to go back up here. I'm going to go ahead and highlight all of this and run it as a batch. So now we'll click on run. And so it takes a second, but now we've got our output. So going back up, the basic model information, the overall fit and so forth, and the regressions and the regression slopes, the significance tests and everything are all exactly the same. The only difference in our output now is that when we scroll to the bottom, you can see that now we've got this section that says define parameters. And so you can see we've got IE1, there's our indirect effect. You can see the z-test results. That indirect effect is not statistically significant. The second indirect effect, you can see it's negative, and you can see that it is statistically significant. The third indirect effect is negative, not significant. The fourth one is negative, and it is significant. So we have basically the second and the fourth indirect effects that we've computed. Both of those are statistically significant. Now, one last thing that I wanted to show you before I kind of wrap up is that in the Heck and Thomas demonstration, they actually utilize a different estimator with M+. They use the MLR estimator, which basically is maximum likelihood with robust standard errors and a scaled chi-square statistic. So I just wanted to show you really quickly how you can accomplish that. I'm going to actually kind of steal this right here. I'm just going to copy it and paste it in down here. We're going to leave our model exactly the same as before. So the only thing we're going to do, we'll just quickly change the name of our fit object from fit1 v2 to fit1 v3. So we're going to leave that as such. But in this case right here, now at the very end, after cluster, we're going to go ahead and type in a comma. We'll go ahead and go to our next line. We'll type in estimator. So we're going to use a new argument called estimator, set this equal to, and then in quotation marks, we're going to type in MLR. So that's our maximum likelihood estimation with robust standard errors and scaled chi-square statistic. Then for our summary, we'll also change this right here to fit1 v3 and leave everything else the same. So now when we highlight all of this and click on run, you'll see, again, takes a second, but now we have our results. And when we scroll all the way up here, you can see we've got the standard test results that we were given before. Again, this was a just identified model, so there's not really much to say about it. But then you can see that we have our scaled chi-square value that's given over here. And then you can see that we have, we would have the CFI, TLI adjusted based on that scaled chi-square value. Then we also have robust CFI, robust Tucker-Lewis. This is actually a little bit different than using the scaled CFI, but those are additional robust statistics. You can see RMSEA and so forth. So I just wanted to provide that just so you know that is also an option if you wanted to utilize that particular estimator. Okay, so that is pretty much going to wrap up this video demonstration. Again, I encourage you to go underneath the video description, follow the links, and again, the data, you can download a copy of the data, and there's also additional information that you can see in terms of what I've done in this video presentation. So thanks for watching, and you guys have a great day.